Ladies and gentlemen, now we have a special address by Mr. Ivan Prokorsky, Executive Director EDMA, Russia, on collaboration opportunities for Russian and Indian electronic manufacturers. Mr. Ivan Prokorsky is leading EDMA, Electronic Developers and Manufacturers Association, as Executive Director since 2017. EDMA consists of more than 180 private Russian companies of electronics industry. Mr. Ivan is founder of Sovil Limited, an agency which is conducting marketing research for Russian electronics manufacturing industry and electronic components market. So can we all give a huge round of applause for Mr. Ivan Prokorsky, everyone? Come on.
Good afternoon, dear colleagues. It is a pleasure to take part Source India. I'm grateful to Mr. Goel for the invitation, and I appreciate to all Elsina team for the support of our delegation, and all of us for the attention and interest. I am Executive Director of the Russian Electronics Developers and Manufacturers Association, and I would like to share some information on the Russian electronics industry, our association, and my vision of the development approach and some insight about current trends in the Russian electronics industry. So, EDMA joined together more than 180 Russian electronics companies. Only electronics developers and manufacturers, only Russian companies, and only private Russian companies. We are very similar to Elsina, the Russian Elsina. And some information on the Russian market. Russia is the second largest market in Europe. Total available market of the electronics equipment is about $72 billion. And electronic components market is about 5 billion. I think it is very close to the volume of Indian electronic components market if we count only Indian products and Indian design without EMS companies consumption, which provides some services for global corporations. There are about 3,000 companies which develop electronics equipment, develop and produce about 100 electronic components manufacturers, including about 20 semiconductor companies. Our association members' products cover all electronics industry segments. You can see it here. And we have very huge opportunities to cooperate in each of these fields. Our association activities, 5 directions. The first of this industry strategy development. You can open the project of the industry strategy with this link. I can share it, and yes, it is in Russian, but you can use online translator. And I'm going to share some theses of our strategy right now. Russian electronics industry nowadays, what happening today, Russian industry continue to grow, and the sanctions drive the import replacement after the 2022, when Western companies left the Russian market. So it was the huge stimul for industry development, but I think it short-term stimul. And now we think about long-term opportunities dedicated to development of technology independence and development of trusted hardware, software platforms for information infrastructure. I will clarify some points of this strategy. What else is important? The independent distribution is very important for technology independence, for independence in general, because authorized channels dependent on foreign vendors, as you know, and it is very risky to share, for example, data of end customers with foreign vendors. So we have to use and develop independent supply chains through different countries over the world. And to produce software and hardware complex, Russian companies use open architectures, which allows them to use multiple hardware platforms. Now, our members use Western chips, Chinese chips, Russian developer chips. We use all platforms which are available in the market over the world. Here you can see 4 different approaches of industry development. Right now we use localization, import replacement as the main approach after the sanctions, but we see the future with technology sovereignty and technology independence strategy to reach technology leadership in several directions of electronics industry. I understand the first one of this approach, labor source development, labor force development, outsourcing is the most organic strategy for the India. But I think we can develop trusted solutions for Russia and for India together with technology independent strategy. What is this? The main focus of the technology independent strategy is on the trusted software and hardware platforms, because digital economy is platformic economy. The companies which develop and manage software and hardware platforms, they manage all ecosystems over the world, in Russia, India, different countries. So if we're looking for independence, we have to develop trusted platform, and it is very important to place design and development in the first layer of priorities before manufacturing. Manufacturing is just some services for developers and designers. To create trusted platform, we have to develop design and development as our first priority. And in 2022, Russian President Vladimir Putin signed the UK's decree about technology independence of critical information infrastructure and about deployment of trusted hardware and software complexes in the infrastructure. We develop this strategy vision and fulfill it by the concrete tasks. You can see it here. 4 layers from the top: information services, platforms of different information services, which provides all of information economy opportunities, and the very important task to provide trusted data processing. Trusted data processing is the first step to the technology independence. Russian companies now use Russian local infrastructure of data centers, of services based on this infrastructure, and so on. This task create the demand for trusted equipment and then to trusted electronic components, microprocessor, integrated circuits, and so on. And after that, as the manufacturing resource, development of semiconductor manufacturing technologies. If we will up the manufacturing up to the top, we will get the technology of manufacturing outsourcing. It is impossible for Russia. It is possible for India. reality for Malaysia and some other countries, but it is not about independence. It is very good for economy development, but here we have to develop some trusted platforms. My vision of Indo-Russian cooperation opportunities here is here. 4 points. The low-hanging fruits is trading and distribution of Indian and Russian products. We with my colleagues looking for Indian electronic components manufacturers, EMS providers, and so on, to develop the independent supply chain network. We can use Indian EMS providers to localize some Russian design, Russian products here in India for the Indian market and abroad. And the most difficult and more important issues to develop together integrated circuits, microprocessors, and hardware platforms for trusted information infrastructure. Now we part of the Source India show. Thank you for that. Thank you for your interest. I invite you to our booth. You can meet the Russian IC designers, fabless companies, power converters, manufacturers, EMS and PCB traders, which can be the bridge between your facilities and Russian customers. We promote some advanced technologies in the ceramic substrates and ceramic components, and very interesting, we will be glad to present the opportunities to develop together trusted operating systems. It is not about export software from Russia. It is about joint project, joint development, and we will be glad to present some instruments for that. Thank you very much.
Thank you so much, Mr. Ivan Prokosky. I request Dr. Sasikumar Gendam, President Elsina, to please come on the stage to give away the memento as a token of appreciation. Can we all give a round of applause, everyone? Come on. Come on, everybody. Let's keep clapping. Come on, come on. Thank you. Thank you so much. Right, ladies and gentlemen, our chief guest for today, Dr. Palnivel Thiagarajan, Honorable Minister of Information Technology and Digital Services, Tamil Nadu, is here with us. Can we all give a huge round of applause, everybody, and welcome him on the stage. I request all the senior members to please come on the stage to welcome our chief guest for today. Come on, everybody. Let's give a huge, let's keep clapping, everyone. Come on, come on, come on. Let's keep clapping. I request all the senior members to please come on the stage. On this occasion, we heartily welcome you, sir. Yes, I request Dr. Sasikumar Gendam, President Alsina, to please welcome our chief guest for today, Dr. Palnivel Tyagarajan. Come on, everybody, let's keep clapping. Let's welcome once again. Yes. Thank you. Thank you so much, everybody. Yes, let's take a picture. We have a small introduction video of sir, so can we play that? Yes, thank you. So I request our chief guest for today, Dr. Palnivel Tyagarajan, Honorable Minister of Information Technology and Digital Services, Tamil Nadu. I request you, sir, to please address the session for today. Can we all give a huge round of applause, everyone? Come on.
Good morning. Thank you for inviting me. Despite the strain of having to applaud for me multiple times before I say anything. But I'm happy to be here. I've just come from another function and I have a couple more to go, so I'm here very briefly. But I notice on the list of sponsors and all the supporting entities from the government that they're all from other departments rather than my own. So I think I'm here more as an ambassador than an actual supporter. Maybe they just send me to speak at all, or I get invited to speak at all conferences. But I had one great luxury today, because I usually get to come, speak and leave. I don't get to listen to anybody else. And today I had the great good fortune of listening to Mr. Pokrovsky and his speech. And it was thought-provoking, right? Because we see ourselves as integrated into the global trade. We think we can buy and sell whatever we want as long as we have the money and the right connectivity. But how do you continue to develop when you're under all kinds of constraints? How do you indigenize things that are otherwise split by expertise into different countries and so forth? So I think the two country partners you have today, one, Russia, for all its uniqueness and its ability to progress with all the plans and schemes they have, and also Taiwan, which is, by any estimation, one of the powerhouses of electronics manufacturing in the world, despite its relatively tiny size. I've had the good fortune of visiting Taiwan a few times when I was a global banker, but never been to Russia yet, so maybe someday I get the chance. But in any event, first let me commend Alsina, which is the oldest organization in the electronics hardware manufacturing space. Also, the fact that every year the SOS conference happens in Tamil Nadu, which is one of the industrial powerhouses of our country. So I'm very happy that this year again it's here, and that so many of you have come to participate. In my understanding, in conferences such as these, the actual interaction, the exhibition, the trade connections, the awareness of the current state of the art, the ability to contemplate new supply links and new business relationships is by far the greatest value add of the conference. And so speeches and panels in general are relatively less important, and in particular, ministers like myself are here more for felicitation than for adding any great deep insight. But in particular, if I'm the IT minister and not that in charge of MSMEs or electronics or industries, it's even more kind of a ceremonial duty. So in that sense, on behalf of the Chief Minister, on behalf of the government, the people of Tamil Nadu, I just want to welcome all of you who have come here, especially those from outside Tamil Nadu, say that we're very happy that such a premier conference in this vital area of electronic components happens every year in Chennai. I commend the office bearers and the local members of the governing council or committee, the past presidents, all of you for continuing to keep this conference with us. I know that it is a vital time in the kind of importance of electronics components, the age of AI, generative AI, and on our way to AGI, automated general intelligence. It is a profound transformation, not just of the nature of work, but also of global competitiveness, of future geopolitical kind of patterns. And therefore, the vitality of this sector has never been higher to any country. I know that in India we have many efforts underway. My good friend, Emeritus Professor at Stanford, Professor Paul Raj is, I think, chairman of the Semiconductor mission for the country. My other good friend, Ajay Chowdhury, is chairing the quantum computing mission, which is also based a lot on hardware. So we as a country are trying to become both self-reliant and keep up with the cutting edge. And all of you who have been component manufacturers of some sort or bigger integrated product manufacturers are really key to our national ambition to stay relevant, to stay strong, to ensure that our children and our future is protected and safeguarded through innovation, through the development of not just research and ideas and design, but actual production and output. In fact, if we can become a net exporting country, it's actually a source of global political strength to be an exporting country. And we have all the ingredients that are needed for that, just like we have been in software, in services. We are today in things like automobiles. There's no reason we shouldn't be a net exporter of large amount of electronic components. And so I thank you again for holding this conference here. I'm happy to see the exhibition in a minute. I hope it will be productive and lead to some multiplier effect economically for all your different industries and for the association as a whole. I wish you a productive summit and conference. Thank you.
Thank you so much, sir, once again for all the support and for all the support towards the industry. Thank you so much once again.
So we just want to acknowledge something which you have done. Yogesh, are you going to present that? So we have created, a QR code and a facility for the students. I mean, it has been done, through your support and from your department. So we have created that. Yogesh, you wanted to show that? Yeah. So it's something which we have done for the students, sir, and they can upload their resumes on this, and I think there are some students here and there are several outside, so we welcome them, and then we will share all these resumes and, with our industry. So we are very grateful, sir. And it's really a privilege to have somebody with so much international experience and exposure. You've been a banker globally and with so many of the top companies, Standard Chartered Bank, Lehman Brothers. So obviously your vision is extremely wide, I would say, and that is the vision that our industry needs. Thank you so much, sir. So this is something that we have done, and we hope that the students here will utilize it. And we want to support the students and the youth to come into this industry. Thank you very much.
Right, ladies and gentlemen, moving on, we have our second session of the panel for a panel discussion, which is on semiconductors and special materials, potential and challenges. The semiconductor and special materials sectors are foundational to the advancement of modern technology, playing a pivotal role across the industries. The expert panelist will discuss the current state of the semiconductor market with a focus on the new challenging journey which our country has undertaken. For the session chairman, I would like to invite on stage Dr. Ravi Bhatkal, MD, McDermid Alpha. Can we all give a huge round of applause, everyone? Dr. Ravi Bhatkal serves as Managing Director, McDermid Alpha Electronic Solutions India Private Limited. Dr. Bhatkal earned a PhD in Material Science and Engineering and MBA from Rensselaer Polytechnic Institute, USA. Dr. Ravi Bhatkal, MD, McDermid Alpha. So, Dr. Ravi Bhatkal serves as Managing Director, McDermid Alpha Electronic Solutions India Private Limited. Dr. Bhatkal earned a PhD in Material Science and Engineering and MBA from Rensselaer Polytechnic Institute, USA, an MS in Material Science and Engineering from Vanderbilt University, USA, and a BE in Mechanical Engineering from the College of Engineering, Pune, India, where he won the Savli Gold Medal. He is widely published, a frequent speaker at conferences, and is a co-inventor on 10 patents. Can we all give a huge round of applause once again, everybody? Next, I would like to invite the panelists. Mr. Sharat Kaul is OSAT consultant with Kane Semicon Bangalore, India, and comes with over 30 years of semiconductor design, manufacturing, and embedded experience. After 10 years with Synopsys, Sharat established his own solar energy startup, Solar Apps Energy Private Limited, providing rooftop solar solutions. At Kane Semicon, Mr. Sharat is responsible for the strategic roadmap as well as packaging, capacity building, business development, and R&D commercialization. Can we all give a huge round of applause, everyone, for Mr. Sharat? I would like to invite on stage Mr. Vikas Dabir, Senior Director, Business Operations Applied Materials. Mr. Vikas Dabir manages India operations focusing on new growth opportunities in multiple segments such as energy efficiency, reliable and smarter grid, energy harvesting, etc. for the Applied Materials India. Prior to this, Mr. Vikas worked at the Santa Clara office as Director for Global Product Management from 2009 to 2012. He moved to India in 2012, joining Applied Materials India as Director of Site Operations and Regional Business Development. A huge round of applause, everyone, for Mr. Vikas Dabir. I would like to invite on stage Mr. Varun Manwani, Managing Director, Sahasra Semiconductors Private Limited. Mr. Varun Manwani, a second-generation entrepreneur, is an economics graduate from Delhi University and has been with the group for close to 25 years since his joining in the year 2000. Starting as a sales assistant at the electronics distribution arm, he has worked in all the companies under the group umbrella and is currently director at Sahasra Group and the Managing Director of the semiconductor venture Sahasra Semiconductors Private Limited. A huge round of applause for Mr. Varun Manwani, everyone. Now, I would like to invite on stage Mr. Ashok Mehta, Managing Director, Suchi Semicon. Mr. Ashok Mehta, born in Babri Sadri, Rajasthan, is a self-made entrepreneur whose journey from a small town dreamer to an industrial leader is nothing short of inspiring. Starting his business career in 1993, he quickly made his mark in the textile export sector, handling nearly 50% of Surat's textile exports. Mr. Mehta took a bold leap into the semiconductor industry in 2022 with no prior experience in this high-tech field. He established Suchi Semicon, Gujarat's first OSAT outsourced semiconductor assembly and testing facility. So I would request Mr. Ravi Bhatkal to please start the session. Can we all give a huge round of applause, everybody, once again? Thank you.
Thank you. Thank you for the wonderful introduction. And I think we've introduced all the panelists, so I don't have to do it again. But welcome everyone to the panel. We have a very distinguished panel today, and what I'm going to do is ask each of them to speak for about 10 minutes or less. On really specifically what their activities are in India related to semiconductor packaging and semiconductor fab as well, and how each panelist sees the ecosystem developing, the gaps that exist, and the policies that would be required to fill these gaps. And then we can go into the Q&A session for the panel. So I'd start with Sharat at Keynes, followed by Mr. Mehta at Suchi Semicon, and then Varun at Sahasra, and Vikas. And I'll round it off from the McDermott Alpha side for materials. So over to you. You can do it from if you're presenting.
Good afternoon. Distinguished members of the dais, the Executive Committee of ELSINA, dignitaries, exhibitors, and dear friends, all the young students, welcome. So happy you could make it today. So I don't want to talk too much about Keynes as much as I want to talk about the issues that we're going to be discussing on the panel, which is about the raw materials for semiconductor manufacturing. But Keynes is a publicly listed company headquartered in Mysore, over 35 years old. We've had a very successful initial public offering and was resulted in a market capitalization of close to $3 billion US. And we've experienced rapid growth over the last few years, and we're now clocking revenues of around $300 million US per year. We have over 22 SMT lines across the country and growing. We have expanded our scope to mechatronics, where we're doing the full plastic injection molds and steel enclosures for complete box builds. And we're represented in around 28 countries across the globe with 360 customers and over 3,500 employees today. So we started out as an electronic manufacturing services company and have done very well. And we saw the opportunities with the government policies and the support. And we realized it was imperative to be self-sufficient, not just as a country, but even as a company. And what that means is we looked at backwards integration. And what we're doing is shifting left and shifting right, which means that those materials that are the inputs for the EMS, we will start making in India. So we created Kane Semicon, which is going to be an outsourced semiconductor assembly and test manufacturing facility in Sanand, Gujarat. And we're starting our pilot line in Chamarajnagar, which is just south of Mysore. And we're also created Kane Circuits, which is actually based in Chennai. And we're going to be doing multi-layer, high-density PCB fabrication. So the previous panel was talking about building a consortium for PCB fab. Keynes is building a PCB fab for the industry. Okay, so we're going to be looking at board counts. I'm not at liberty to talk too much about it, but let me just tell you that the facility we're building are not just to catch up, but to leapfrog. We're going to be doing over 50-layer boards, and we're looking at advanced technologies for India and for the globe. With regards to our packaging, our initial focus is going to be on what's called legacy packages. But those legacy packages, what we're planning to do is invest in research and development to add value to those packages by putting advanced technology silicon in those legacy packages. And our initial focus is going to be on high-power electronics. And when we talk about high-power electronics, we're talking about materials like gallium nitride and silicon carbide. And the specific components are called IGBT. Was anyone aware that India is going to be the largest buyer of escalators and elevators in the world? IGBTs are used at the heart of these. EV battery charging, we're going to be going from 4-hour charging time down to 10 minutes of charging time. There's no other way to do it unless you have high current and high voltage. So digital CMOS fabs and display fabs will not meet that. It's the compound semiconductor fabs. Compound semiconductor fabs have less cost and investment, and the market in India has a voracious appetite for these. So we are looking to put these high-power silicon compound semiconductor dies inside of legacy packages to start with, and then we are going to be progressing towards more advanced packaging, which is, I would say, mainstream in the globe, but advanced for India, and that would be flip chip BGA and BGA packages from wire bond. And eventually, the entire globe has been working towards higher throughput. Today, we have fiber optics connecting continents, but research and development has been going on for the last 20 years on what's called photonics and co-packaged optics. That means using photonics between chips and between boards. This will be a game changer, and India has an opportunity to leapfrog and stay ahead. So there's a significant amount of research going on in the country today, and we're really looking forward to the journey ahead. So with that, and I have one more slide, which kind of gives you a representation about the problem stays. Ravi had asked us to put this slide together for some work we're doing for research and development. And I thought I'd just post this here. It gives you a flavor of, on the x-axis, of course, any silicon and any transistor, whether it's compound or whether digital CMOS, is basically a switch. So, and the metric is how fast you can switch. So on the x-axis we have frequency, and on the y-axis you have voltage. And then you can see where silicon carbide, where gallium nitride and IGBT, what spaces they possess. And always remember that the roadmap looking forward for the next decade, for the next 4 decades, these numbers are not going to go down, they're only going to go up. USA today for 4-wheelers is already charging at 250 kilowatts. India's 2-wheelers are at 60 volts. that voltage needs to go up to thousands of volts. The currents need to go up to thousands of amps. And the only way to do that is through high band gap materials like gallium nitride and silicon carbide. So with that, I'll conclude. Thank you so much for your time today. Look forward to this session.
Thank you, Sharad. Mr. Mehta, can I ask you to give a few words after you?
First of all, thanks to the team of Alcina who invited to me for this event, and thanks to all the teams who is arranging the very nice exhibitions for the helping to the Indian industries. Suchi Semicon, this is just a newborn babies. We started this journey in 2023, and December 2024, we started our Gujarat's first OSAT plant in Surat. Now, we are initially in that trial run and all that, but hopefully for the next financial year, we are starting our commercial productions. Basically, we are not from the technical industries, not electronic industries or not any technical industries. Our background is totally different, and we came from the textile industries and now diversify in this semiconductor industries. At the time of COVID, when whole world facing the crisis of the semiconductor chips, at that time we thought why not entered in these industries, and after a long research we come to this point, and ultimately we reach to our destinations. The main challenging in India is the workforce, because this industry is totally new and we cannot get the trained people who can handle this technical industry. But we arrange the top professionals, and after that we hired so many BTech and MTech students from the various universities like IIT, NIT and various colleges. And since our last 6 months, we are giving the trainings to that student how to run these industries, because they learn theoretically in their college, but practically they can learn in our institutions, our factories, how to run the machineries, and this is the challengeable job for him also, because the quality is the major factor of these industries. It's a very, not I can say difficult industries, but it's a very difficult industries due to maintain the international standard, because our most of the buyer now the companies is from US or Europe or any international standard. We have to give the international standard, the quality to the customers. So this is the big challenge for the workforce, but India is the hub of the talent. Now in the semiconductor chips designing, if you are thinking about that, almost more than 300,000 engineers working on that semiconductor chips designing. So all there is no doubt about the talent of the Indian students. When we can talk about the R&D, we already set up an R&D center in Gujarat, and one R&D center we set up in that Malaysia. Because Malaysia is the hub of these industries, Philippines is the hub of these industries. So we already set up one R&D center in Malaysia, so we can get the solutions if we had anything, or what is the future, which package will be the future. Our R&D centers will regularly focus on that. Now the government policy from the ISM, they are giving very good support to, maybe still they are sanctioned only 4 companies, but in future maybe they sanction more than 6 or 7 more companies for that. The PLI scheme, all the state government now initiative for the subsidies, all state government giving the subsidies for that semiconductor industries. So we can get the benefit of that industries. And now if it's a very captive industries, it's a huge capital investment. So without government support, we cannot establish this type of industries and this type of factories. Now government also take the initiatives for the students, for the training period. They give the incentives to that students, they can come for the internship. So we can build a good strength of that technical team in India, because this is the future industry for India. Now I know so many universities started that semiconductor courses. Even we also having MOUs with more than 500 colleges. And our technical team support all the college, all the principals, which syllabus they are want to run, how to learn that students, how to give the training just for a week or 2 weeks or 3 weeks at our factories. So we are doing like that also. And thanks again to invite to me, to Alcina and all the team. Thank you very much.
So Varun, can I ask you to say a few words, please?
Thank you, Mr. Ravi. So during my introduction, the young lady introduced me as the second generation entrepreneur. When we started our business, in which my father started back in the 1990s, we started our journey as a PCB fabrication company. At that point of time, when we started fabrication of PCBs, we did not have any collaboration with any company in the PCB fabrication space. So there was no technology collaboration, there was no other kind of financial collaboration. And life has in a way come a full circle, because approximately 30 plus years later, when in 2020 we decided to get into the semiconductor packaging business, again Sahasra did not look at having any technology partnerships or engagements at that point of time. So we started with a component, the PCB fabrication business, which is PCBs are basically a component. Then we moved into, in the 2000s, we moved into the EMS industry, and we started the assembly business, which definitely helped us grow quite a bit. In the assembly business, as you go up the value chain, from a component to assembly to a product, as you go through the value chain, your product value increases and so does your revenue. However, in 2020, when we started the semicon packaging business, we once again came back into the component industry. Now, just, how did we enter this business? So back in 2020, the semiconductor shortage had not yet started. So for us, definitely the reason to get into semiconductors was not the shortage. We were working with a very prime Japanese customer in the 2016 to 2019 period. And that's how we got into solid state memory business. And during the solid state memory business that we were doing the maximum value addition that we could at that point of time in India. And that maximum value addition was not more than 23%, with us fabricating the PCB for the thumb drive or the USB drive. And so together with our customer, we decided that we should backward integrate and we should get into packaging. And that's when in 2018 end, the idea of packaging was born for us. Unfortunately, this Japanese customer decided to quit the memory business worldwide. However, that left the seeds of packaging in our mind, heart, and opportunity presented itself in 2020 when the pandemic started and the very first PLI scheme got rolled out by the government. And so that's when we decided that, yes, we'll get into semiconductor packaging. To our bad luck, ISM was not announced by then. However, we did take benefit of the spec scheme, and we have recently submitted our application for getting our subsidy back from the government. There are a lot of parallels between PCB fabrication and semiconductor packaging, and I think that helped us to a large extent. Because in both cases, you're dealing with materials and the output is electronics. The manufacturing of the same is not really electronics. So that was our journey in how we got into the semiconductor space. Having said that, we became the very first company to get into packaging. We did our trials between the 2022 to early 2024 period, and we have now gone into commercial production as well. At our semiconductor facility, our OSAT facility, we are looking at two types of packages or two types of businesses, I would say business lines. One is the memory solutions, and so because we were in the solid state memory space, that obviously became the very first choice for us. And so we are doing micro SD card packaging in India. The second is, we chose to look at legacy packages to begin with, because legacy packages was the very first stepping stone for us to be able to get into the arena of the big boys and be able to prove ourselves. Now, hence 2021 when ISM started and when the semiconductor space started gaining ground, there are so many companies stood in this space, the entire ecosystem is developing. But back in 2020 again, that the biggest challenge was that what do we do, how do we do? And so we started analyzing some markets and where the demand is, and we struck upon the LED lighting segment. And therefore, we decided to do the packaging of the LED driver IC, which, by the way, is 100% imported. And you can guess the country from where. So with that, we decided, let's get into the LED driver IC, which happens to be a SOP package. And so that's where we, looked at getting into this particular business. And it also, it was also a very big stepping stone in being able to, when we started to look at paying customers, the realization was that until and unless we build a package ourselves, no other customer is going to believe on us, or rather they will say that, don't make us the scapegoat. And so therefore, we decided that we should build a package for ourselves, which the industry will need. Let's make ourselves the scapegoat, evolve during this particular journey, which we have done. We have gone through our pains and challenges and we continue to do so. But where we are today, we are very happy with our results, our pace. Yes, things can always be better, but I think we are very well poised, and the packages that we are doing today on the legacy side, which are SOP packages, DFN, QFN packages, and thereafter, we will be getting into QFPs, etc. On the memory side, we are doing micro SD cards, as I mentioned, and then we will be, in the next 18 to 24 months, we are going to look at the advanced packages, which will be BGAs and NAND flash BGAs and eMMCs as well. So this is just brief about our journey through this business and about the operations of Sahasra. So from a PCB company, which we still have, we moved into EMS and we came back into the component industry with semiconductor packaging. Thank you very much.
Thank you, Varun. Because welcome and the big dog in the industry. So
that's a great phrase. Thank you. But what a pleasure, right? I mean, I look back at when India started talking about semiconductors in real time, that late 90s, Intel started looking for a fab outside and we were all in US excited, hey, somebody is going to go to India. Maybe one day I'll be able to go. We have come a long way. And I'm sure Ravi can relate to this. I'm seeing those fruits now, what we have been advocating. I came back to India more than 10 years ago. We have been advocating with the government on multiple different things. Elsina as a platform I like because it brings the three stools of the industry together. And what are the three stools? The number one is a customer. We represent the customers. Elsina members are suppliers. They are members who have medium scale industries, small scale industries. And the third is the government. All three can come together to really recreate what took 30 years in China, we can do it in 5 years, 10 years. Because we have willing partners. There are a lot of things that are today apparently turning in our favor. We have a great R&D, semiconductor R&D team, more than 100 odd companies. So we have that base. We have the government that really is taking actions. Some of our previous panelists mentioned, they are not only listening, but they are being proactive. And I can tell this because I've been working with the government on many such things. And the third thing is companies like us, which are large global players, are increasing the footprint in India, not only for R&D, but for different things like supply chain. So all these three things come together, has a great potential to really make India billions of dollars into this game. When we look at the whole ecosystem of semiconductors, it spans a lot of things. I heard a lot of the panelists, earlier panel, this panel, talk about the various segments, right? Whether it is PCB, making the bare PCB, PCB assembly, the components, the capacitors, the diodes, the passive components, then the OSATs that will make the chips, and now Tata putting up a fab. And there are lots of other fab opportunities, whether it's in compound semiconductors or what Sense is doing in high power, especially for the Indian market. But the key here is to take technology and make it global. So let's come to Applied Materials, right? Applied Materials is a big multinational. We are one of the biggest equipment suppliers along with the technology. So what do? We actually develop equipment working with the customers like Intel, TSMC, Samsung, others, or what the next node should be. And how do we do the equipment to deliver that node? Make the transistors of those nodes. They are, of course, getting the inputs from customers like Qualcomm, NVIDIA, etc. So we are integral right at the top of the food chain to develop technologies that will get into our cell phones 3 years from now. So just understand how ahead of the curve you have to be relevant in this industry. So that is the first part of what suppliers who are interested to get into semiconductors have to think about. Patience. If you don't have the patience that it takes time for you to get qualified, for you to develop something, and then it goes into a product which will start making revenue after 3 years, this is not an industry for you. But the potential benefits of that are also equally great. Semiconductors work on the latest technology, but they are one of the most conservative industries. They hate change. Once you get qualified, you stay qualified. They don't like to make changes because we spend so much effort in getting a product out, and it becomes very expensive every stage of it. To make a wafer, it takes around 3 months, and the value addition happens at every stage. After that, you build the chip, the OSAT, then it goes into a PCB assembly, and then it goes into an end product, whether it's a laptop or a cell phone. So the value addition at every stage is very, very high. And any one change can impact anything. A change made in the machining supplier I make may end up in your cell phone not working. I know it's far-fetched, but that is how this industry is. So first thing is patience. Second, this is a very technology intensive industry. I think he spoke about it. Mr. Ashok spoke about it. You need strong engineering. You need to put engineering resources now for something that will come in the market 3 years from now. Something you'll make profits maybe after that. But if you are not ready to put those engineering resources, you're not going to succeed. You may succeed initially, but this is a technology that evolves continuously. In my 25, 30 years in semiconductors, I've just seen n number of changes. And if you don't stay relevant, you will die. And many, many companies have gone. We are seeing one of the biggest companies for 5 decades is struggling now. So success is not guaranteed if you do not stay relevant. So the engineering resources, putting those things are very, very critical. The third thing comes the capital. You will need to be ready to invest something different from your existing infrastructure to meet the stringent requirements of semiconductors. And this is where the government is helping significantly, whether it's through the spec scheme or ISM scheme. And the government is listening. Now, how do we all put this together? So I can tell you from experience, in India, we have the talent, we have the suppliers who can make it. But finding that supplier who meets all these three is not a straightforward task. So my request to Elsina has always been, find the suppliers. So I'll give a simple example. Today, build to print parts, we have lots and lots of suppliers in India. But for inner capital equipment that we make, along with the machining, you need some special processes. Those special processes are customized. Customized for applied materials and in turn customized for our customers, whether it is Intel or Samsung. So it's not that the same part that is used in Intel will work in a Samsung process. So that customization, so we call that special processes. So you need to get qualified for the special process. So there may be some investment for that. So it is along with the third piece of that is for making that assembly after the machining, doing the special process, there are very, very small or what we call as OEM components to make that assembly work. And that is our biggest challenge. Because we are low volume, high engineering content, you need to be able to think about a global market. If you can get all these three together, you can start thinking of revenues globally in billions of dollars. And like I said, you get qualified in a node, you get qualified at a supplier, they will not change you easily. So moat is very strong. But there are multiple steps that you need to go through. So one request I've been talking to yesterday over dinner with Elsina thing is, can we do a webinar to explain the type of OEM components? Then the OEM components can go with the machining suppliers or sheet metal supplier or other build to print suppliers to create that additional value. Now, the other important thing that is in India's favor is all the global development centers like us. We have large R&D facility, we started R&D. In the last 4-5 years, we have started expanding into these other avenues, supply chain being one of them. Following us, our closest competitor just announced 2 days ago, a big site, a big investment in India. GCCs across the world, not only in semiconductors, in all other fields, are looking at India as a great opportunity for multiple reasons. COVID also showed us resilience is very important. You cannot be relying on a single source. So that has opened up more opportunities. The geopolitical situation is fragile. There are ways how it can benefit companies in India. We need to leverage. So opportunities are fantastic. We are talking of $1 trillion market. $1 trillion is 1,000 billion. So you know how big that market is. And we can have billion-dollar companies, not only the startups who are doing e-commerce, but in semiconductor hardware. That is the vision you all need to get excited about. And we are here as end customers to help you. What are the requirements? How do you get qualified? What is special about semiconductors? And the government is there to support you all in every way, whether it's in capital, subsidies, PLI scheme, and other things. So leverage companies like us, leverage the government schemes, build your engineering teams that can develop this and look at the long term. If you have the patience and these 3 things, you can do wonders. The companies I've been involved, I've seen companies do this in Korea, in China, in Taiwan, in Malaysia, and now Vietnam is doing it. Our competition today is Vietnam. We can do a good job like Vietnam or even better, but we need to grab that opportunity. And yesterday, one comment by one of the panelists struck me, and I wanted to repeat that. When a customer sends an RFQ for a quote, suppliers in those parts of the world can turn that around within 2 hours, is what I heard. That is the aggressiveness we need. We got to think about how we can capture the market. How do you grab the attention of these companies? How do you grab the attention of those customers? Be aggressive in your approach. Develop those skills in-house. Have the software for doing your should costing, if it will, and be as quick, as dynamic as those customers. Your competition is intense, but we have a very good chance because of all the reasons I mentioned. Look forward to this conference. I'm very excited by looking at the booths as well as this panel. Thanks.
Thanks, Vikas. That was inspirational, as usual. Thank you everyone for the comments. So I'll speak to the materials part of this panel. So McDermott Alpha is a advanced materials and specialty chemicals company. Our parent company goes by the name of Element Solutions. We are a public company in the US on New York Stock Exchange. The root of the company is more than 300 years old. We're overall, globally, we're about $2.5 billion, which in Indian rupee terms is in excess of 20,000 crores. In India, we've been manufacturing as a multinational for, this is our 94th year now, since 1931. Of course, we started in the smelting area, there was no electronics at that point in time to speak of. But over time and over the last 2.5 to 3 decades, we have really helped build the electronics industry in India. I mean, that's the truth. So we go from chip to box anywhere where an electron goes from back end of line semiconductor, the fab portion of it, to connect the devices on a wafer. We make all of the damascene copper chemistries for that, going down to very advanced nodes. We introduced that to the industry 28 years ago, and we've been working in it ever since. We make chemistries for redistribution layers to fan out the signals, and also bumping chemistries for both copper and other alloys and materials. We make all kinds of semiconductor packaging materials, including regular your die-attached materials that are used for dispense and die bond and wire bond type packages, all the way to very advanced technology, which is sintering now, which has become standard in the industry for silicon carbide and gallium nitride attached. But there was no application 12 to 14 years ago. We basically developed that space. We helped the equipment suppliers evolve and design for high volume production, and now it is in high volume production globally. The biggest applications being in electric vehicles, but then now plenty of applications emerging for silicon carbide and gallium nitride in the space. And that evolution will continue. We also make interconnect materials and surface finish materials for IC substrates and printed circuit boards. So all your PCBs contain our chemistries and materials for conducting electrons and ensuring that solderability can be assured. And then we make a wide range of assembly materials, soldering materials that are used to assemble components on boards, and the protection materials like conformal coatings, encapsulation materials, and thermal management materials for the finished systems. We also have another division that makes electroplating chemistries, that some of which are used in box build and fasteners that are used in the electronics industry. Everything from aluminum anodizing chemistries to zinc chemistries for box build, and zinc nickel chemistries for your fasteners, screws that are used to assemble finished products. So it is literally a true statement that we go from chip to box. It's a fairly unique place in the industry, because I don't see another company that has this range of the slice of the market, so to speak, and it gives us a very unique perspective of the entire global electronics value chain. So we are in about 50 countries. As I mentioned, we've been in India for a long time. We're headquartered here in Chennai. We've been in Chennai for 50 years. We have a global R&D center in Bangalore, which is one of our largest globally and does very advanced work. We also have a manufacturing facility in Pune for electrochemical chemistry technologies and products, and then a technical test center in Manesar in Delhi, focused more on the automotive sector. So that's about our footprint. Now, where are we in terms of, how do we fit in terms of the evolving market in India? We're sort of helping to localize a lot of the technologies and move in the direction of semiconductor packaging and eventually fab as things start coming out and installed. We have partnerships with major equipment companies in the semiconductor fab and packaging space. I think you've heard Vikas talk about Applied localizing substantially in India. So has their primary competitor, I would say. And I think more of that will follow, because one of the things I can tell you very confidently is that the talent is there in India. There's no question about it, that the brain power is very much there, right? It just needs the certain components to be added to that mix, which is the right kind of education and training, and also the right kind of infrastructure and capital that's required to be brought to the country to enable that, those pieces to fit together. And of course, capital, you talked about the capital portion of it, financial capital. But financial capital is there. There is literally no shortage of money today, and I think there's smart money looking for very good investments that's going around. So we've been, I can say, we've been involved. I felt about 6, 7, 8 years ago that it was very important to start building the people. I mean, workforce development and the people pipeline. But more importantly, it was important to start really getting the people, students really exposed to real world applications and actual production lines and systems. And so we took a decision about 6 years ago to put production lines on campus. If you look at the ecosystem, you can look at it as people, materials, components, equipment as the inputs, and you've got activities like design, modeling and simulation, manufacturing process, and then testing and reliability. If you want to build the entire ecosystem from fab, packaging, board assembly, and final assembly, you have to put these 8 pieces together for each of those nodes and build a robust capability in terms of ecosystem. So we started doing that with board assembly. So we put production line at IIT Madras as part of the center. We put one in College of Engineering, Pune. The third one will be at IIT Kanpur. And then we've seed funded semiconductor packaging labs at both IISc and IIT Bombay to start with. And we are working with Professor Rao Tumala, who's leading the effort to build a network of centers around the country in IITs and ISC to really put advanced capability and people in place for workforce development, research, and capability that industry can utilize. So pretty soon you'll see this network of very advanced capability come to universities and research institutes with, this is a global effort. So there's probably 60 to 70 companies that are involved, both from India as well as globally in this effort. And to be quite honest, I'm very excited about it. I've given a lot of my own personal time to this, and it's one of my passions. So shut up also. And so I am incredibly optimistic that the ingredients are now falling into place. I don't think there's anything stopping this freight train from going forward, to be honest with you. The geopolitics of the situation, it just helps the situation, what's happening with the geopolitics. So you're seeing, and I'm seeing, frankly, an acceleration of the level of investments going in, because, we started with the initial announcement of the Tata fab, then the Tower Semiconductor and Adani, then I'm looking at least 3 other compound semiconductor fabs that have been announced, the IDM and OSAT investments that are going in, and then people like us on the materials side making more and more investments and localizing more locally yourselves from a fab standpoint as well as advanced packaging. But I think a lot more equipment capability will come into India. So I'm really excited about it and very optimistic and looking forward to it, to be honest. So thank you to the panel. I think maybe we can move to a few questions, if that's okay, and then open it up to the audience. So one of the questions I had was, in terms of R&D, but also not just at the university level, but internally, and what are your thoughts about expanding that capability in India? I know you've set up an engineering center already here. Do you have plans, for example, to bring more into the country? And maybe we can have all of the panelists answer that question from what are your thoughts and plans to localize more R&D in your own facilities and companies?
I'll just add, you may have all seen the announcement we made a couple of years ago. We are setting up a very advanced lab here with full 300 capability. So that work is progressing as we speak. That will bring that dimension that we were not having in India, that is process capability, processing wafers actually. So whatever we design, whether it's an electrical, mechanical part of the system, how does it really work? Can I take that data and go to our customers and show, hey, this part works? So that was a missing piece. Of course, the advent of customers like Tata goes a long way to create completely new avenue of capabilities here. And we have the talent, like you mentioned.
Thank you. Mr. Mehta.
We already started the R&D center in India as well as Malaysia, and that R&D is the backbone of these industries because the electronics is the future, and every day we think about this R&D and future developments. So initially in our company we started with that legacy packages, but future we are planning at least for 3 years which packages we are going to do. So our complete team we are appointing for the R&D, and in Surat also we have the R&D team. So they are studying, and now I can say we are in the initial stage, but we are thinking and we are planning for the future next 3 years. So we already appointed some PhD holders and top IIT guys for that purpose.
Thank you. Thanks. Varun? Yeah.
Sure. So we look at R&D at Sahasra in two different forms. One is process-driven R&D. You know, we cannot all just start designing packages, right? So we have to also look at process-driven or material-driven R&D, which is not only being done by material companies like yourselves or equipment companies, but also process and materials in our own space. For example, you know, you're using a particular wire in wire bonding, and can you do R&D so that you can do a value engineering by using a different wire so that you bring down cost for your customer, right? So that's also a form of R&D. So we'll be doing things like that as well. The second is the R&D on doing package design. Now, we are looking at not necessarily package design, but we're looking at more of substrate designs, lead frame designs. When it comes to the package design, we don't want to compete with our customers. So we will be leaving that to the customers. And secondly, we at least at Sahasra believe that when you look at the industry in the US, in Europe, in China also, the design houses work very closely with OSATs and fabs. And so, again at Sahasra, and that's how we look at it, if we start getting into package design, then we're competing with customers, we're competing with our R&D houses. So for us, our R&D is defined as process R&D and R&D around, as I said, could be materials, working with material suppliers. It could be substrates where we are looking at how do we miniaturize it. So that's how we look at R&D at R&D.
Thank you, Ravi. So look, R&D is only as good as your ability to bridge the gap between R&D and high production yields. What's the use of having R&D at 20%, 30% yields when you need 99.999999% yields in production? How do we bridge that gap? So these are one of my responsibilities in Keynes is how do we commercialize the R&D work? So the PCBs that we've seen over the years are shrinking in size. The components are getting consolidated. And the holy grail in our industry, whether it's equipment suppliers, whether it's raw material suppliers, whether it's OSATs, whether it's fab, is PPA. Power, performance, and area. These are the crown jewels. Now, those boards are now becoming modules in themselves. Those boards are becoming chiplets, heterogeneous chips on these boards are now becoming into one single monolithic device. And the R&D is focused on that path. And there's multiple vectors that we have to address in order to meet that holy grail of power, performance, and area in a single monolithic heterogeneous device. PhDs. We need PhDs focusing on advanced packaging. And the PhDs, you can say the IITs, but there's fantastic engineering colleges across the country. Fantastic private engineering colleges with fire in the belly, with that drive and determination to contribute to the country. We have a bigger challenge, and as electrical engineers, material scientists, how do we not let these brilliant PhDs escape to the IT industry and computer science, and how do we make them into hardware engineers? So this team over here are all working to try to build awareness about what semiconductors are, the importance of it. And our honorable minister has said time and time again, semiconductors is the foundation, like steel, of the world. So PhDs, quantity of PhDs and focused PhDs are a must for our R&D efforts. India, being a democracy, has an ability to work in hub and spoke method across the country with our 23 IITs and to address various aspects of R&D towards that holy grail of the monolithic device. The second thing is partnerships. Partnerships at a global level, and then partnerships at every stage of the value chain. Partnerships with companies like McDermott Alpha for the raw materials and advanced materials, polymer, films, solders, high temperature bonding, hybrid bonding, substrate design, substrate materials, advanced substrate material, moving from silver to copper, high thermal conductivity, high power density. We can't do it without partners. Partners means technology transfers. Technology transfers means that the manufacturers can make it available to our customers. PhDs, partnerships, and then of course the customers. The customers and bridging that what's so-called the valley of death between academia and high volume production. Believe me, my friends, this is one of the biggest challenges we're going to face to get out of this mindset of proof of concept in this country and to understand how do we commercialize this, get it out of the labs and into the hand of production houses. And it has to happen with the focus on power, performance, and area, monolithic, as everyone's common goal, and then bridging that gap between academia and proof of concept to high volume yield production. And I'll just close by saying it's just common sense. India is very strong in development of chips, and fabless semiconductors is doing very well. India has around 20 to 25% of the global design workforce, and Indians in India are working on the most cutting edge designs on the globe, but maybe not for India. Now, how do we take those designs and into the manufacturing phase is what we're faced today. And we have a gap of from design to back-end manufacturing, this fab area. So we are going to be looking at a little bit more mature nodes. And it's a smart move because of various reasons and geopolitically, which we're not going to talk about today. But how do we bridge that gap from that strength of design to the back-end manufacturing? And that's all of our challenges now. So thank you.
Thanks, Sharad.
Ravi, can I just add one comment? Especially the point that Sharad made, right? Partnerships. I think we, as a country, have a huge opportunity in the material space. The whole value addition in semiconductors requires materials, materials, materials. Whether it is a PCB or advanced packaging, everything is materials play. So partner with a potential end user, all of them are here, partner with them and have a long vision. You got to put in the scientists to look at the materials play that can be commercialized. I think he made a great point. Work with partnership so that whatever you all design in R&D will actually see the light of the day.
Thank you. Absolutely. I think we're running just about 5 minutes left for the session. So I'd like to just open up to the audience. If there are any questions from the audience to the panel, I'd be happy to take them. Sure.
Just as an observer of the industry, I'm amazed at this panel. If you look at the spectrum, it shows, the entrepreneurship of, the Indian mind, of the Indian businessman. We have, applied materials. We have, Sharat from Keynes, and I think with a background which is definitely from, multinationals and overseas. Then we have, materials. We have, Ravi here, which is also a multinational, another high tech. Varun, of course, a great entrepreneur and has, jumped into, and I know his father so well, they have jumped into this, into the fray. And it's a very big risk that they have taken, there's no doubt about it. And last, but definitely not the least, cannot leave Mr. Mehta out of it, who has definitely taken a leap of faith, and I'm sure his son is behind it. Because his son is a younger man, and I think, we met him yesterday and, earlier also once, when we were there in Ahmedabad. So I think this actually, raises a lot of hope that if such a wide spectrum of, technocrats, experts, entrepreneurs are in the fray, then that day will not be so far off when, an ecosystem will be built. Because this is a very, very complex industry. I don't understand it. I'm just trying to understand a little bit of it. And we need a lot more players to come in. So I think, but it's great to see that such a wide spectrum is there and, there is faith.
Thank you, sir. So I actually wanted to continue that train of thought about the design, and I wanted to talk about something. I go all over the country addressing students, and I always ask them the question, if I produce 1 million chips a day, what should be my yield? I've asked IIT, I've asked professors, and 9 times or maybe 10 times out of 10, the answer is 80%. I don't know why they say 80%, but they say 80%. So then I tell them, I go, 80% of 1 million is how much? 800,000. So how many fail? 200,000. And then they start scratching their head. Just imagine you have spent millions and millions and millions of dollars over the course of 3 years designing that chip in Bangalore. Teams of hundreds of engineers build that chip. Then you fabricate it in the most advanced technologies in the globe, which cost billions and billions of dollars. These use IPs that have been silicon validated before going into that chip, which cost millions and millions of dollars. Then you hand over this wafer. I don't want to call it a wafer, I want to call it gold. I want to call it diamond to the packaging guys like us. You think they'll allow us to dispose 200,000 of those? Impossible. Start thinking practically and common sense. This challenge, we throw it out to all of you. How do we bridge that gap between this proof of concept to production grade yields? Because I'm telling you, if you're below 85% yield on wafer fabrication, you're going to lose money. If you're below 95, 98%, 99% on final test, when we test it, you're going to lose money. So the area in test is enormous. The opportunities in test and validation, reliability and failure analysis is enormous. Bring out your debugging skills. People that have logic reasoning and debug skills will exceed in this market. And it is the need of the hour. Thank you.
Thank you.
Mr. Rav, on the panel.
Oh, sorry. I was wondering who was talking.
So I just wanted to make one additional point. We did not talk about, I mean, during this panel, we probably did not speak much about supply chain. And I'll address that because the theme is Source India and we are talking about enhancing India's supply chain. So in the morning sessions, you know, when the companies that were sitting together, which is product companies, EMS, PCB companies, they had some complaints about supply chain not being there. Now, if you talk about the semiconductor industry, we start from negative, I think, right? So, just wanted to make that inference that situation is better off at this time and age today for the semiconductor industry in India. The supply chain is a negative because even if a blade breaks, we wait for 5 days for a $1 billion machine or $1 million machine for the blade to come from somewhere. So no doubt in the last 4 years, the ecosystem has developed quite a bit. Also, India is a lot more complex because when you talk about all the semiconductor leading nations, which are primarily island nations, you have to cover a very small distance, right? China is the only other example which, has done that very well. And so one of the prominent Japanese equipment suppliers was telling us that over the last 25 years, they built 17 offices all across China. So we have built the first office here in Bangalore, and I was like, you don't need to wait for 25 years to build another 17 here. It has to be done quickly because the talent exists, the market is there, right? So the supply chain is very, very critical across materials, across equipment, across. Not only do we need workforce for running our OSATs or fabs, but we need a workforce for maintenance. We need workforce for maintaining the clean rooms, for maintaining the, and again, those are, I mean, we've not spoken about those areas, but those are areas which are hugely challenging. You're talking about 99.99999% purity of materials, and some of the suppliers just don't even understand that. So there are challenges, but yes, there are some good points that have happened over a period of time. As you said, access to finance is become easier. Definitely, there's so much more focus in the industry on semicon, and so that brings in the ecosystem faster. And definitely, there's no dearth of human capital. Yes, it has to be, the skills have to be honed upon. And I think collectively, all of us as an industry are collaborating with academia to be able to bring them closer to what we need and make them productionized.
I'll just add, challenges equal to opportunities. What is a challenge for you is opportunity for all these people.
See, I am one quick question here.
Thank you.
Yeah. So I'm one quick question.
Okay, sure.
Yeah, one quick question, more of from an experience sharing basis, maybe relevant to Varun and Mr. Ashok Mehta. See, if somebody has to set up a very basic electronic manufacturing facility, say microcontroller or a PCB, one of the inherent risks the entrepreneur has or hesitation is that by the time he reaches the global quality standard, that cycle is too long. How did you manage to compress it? How did you manage to surmount this risk?
When you start from your home, there is a risk. Someone accident to you. So in any industries, when you diversify, there is a risk, definitely. And any entrepreneur start it, he think more than 100 times about this diversifications. He studied what is that plus point, what is the minus point, how I can reach there, and after that, any entrepreneurs decided to go in that industries. As of me, I studied about 3 years almost about these industries because I am non-technical people. Even my son is also non-technical people. We are coming from the textile industries, and I will tell you one thing. Our Prime Minister Narendra Modi, sir, talk with our cabinet minister, Mr. C.R. Patil, who is inaugurated our factory, he asked to them, this person came from the textile industry, how he can come in this semicon industries. So that is, and I give the questions to them. Tata came from the textile industries. Reliance came from the textile industries. Birla came from the textile industries. Dalmia came from the textile industries. All the top big industrialists, startup was the textile. There is no barricades for that which industries you come and where you want to go. So risk is there, but if you are completely studied about your project, there is no risk. Nowadays, I am not feeling any risk in these industries. I am 100% sure I will succeed in these industries. Thank you.
I'll just add two comments from my side. Obviously, Sir has already mentioned everything. The word entrepreneur is synonymous with risk. So it's not only about semiconductor. You start a bank, you start a textile business, you start the car manufacturing business. Everything is risky. But as an entrepreneur, you also take leaps of faith. You don't just look at, I mean, you cover your bases, right? And you don't just get into something in a foolish fashion. But you also take a leap of faith beyond a point. And also, there are many other things, I would say, like timing, right? If you have deep pockets, you can enter an industry later. But if you enter the industry at the right at the right time, that could be very, very important to your success and failure. So just a couple of things from my side.
So, having been doing this for so long and having been an entrepreneur myself, a failed entrepreneur, and I take pride in saying that because I learned so much and it's made me stronger. There's no free lunch, there's no shortcuts. It's hard work. You have to traverse the miles. Also, try not to, I always say this to budding entrepreneurs, don't build it and then hope that people come. You build it based on the customer's requirements. This is the difference between an engineer and a businessman. The engineer says, oh, my product is the best in the world. Oh my God, my product is, everyone's going to come running. You'll be very surprised. So if you want to get into the electronics manufacturing service, find anchor customer, stick with them, don't lose them, and also try not to chase, as a starting entrepreneur, too many areas in PCB. Be very focused. I'm going to do a wireless application. I'm going to do a wired application. I'm going to do a telecom application. I'll do a railways application. I'm going to do a high power device. So look, be very, very, very focused and have an anchor customer. And again, there's no free lunch. As Sir was saying, you may not be an expert in technology, but you can surround yourself with technology people. You can get good people. And as a leader, you have to inspire them, right? So you don't have to be a semiconductor device physicist or a PhD. You can be an entrepreneur who has common business sense. And I'll tell you one thing. He's saying textiles and light, but the way that the textile industry has evolved over the years, from the chakra, to the loom, to the mechanical loom, to the automated loom. Did you know that's all done by our ministries of heavy industries? And that is a seed to manufacturing. So he might be saying it in light, but actually it's a very poignant point he made. So with that, I'll conclude. Thank you.
Thanks everyone for wonderful comments. One more.
Maybe one last question. Yeah, sure. This is Rahul Prajapat, co-founder at Twarit GmbH. Almost after 10 years in Germany, I am currently on my India visit. We have worked with the likes of Infineon and all on Vico equipment, and our focus is machinery basically. That's the niche which we have done. We essentially collect defect data and correlate it with the process data to make AI models, and our tagline is zero defect manufacturing. Now that's why my question is only related to this space. Is India also growing its own sort of equipment manufacturing space? I know Applied, for instance, Lam, etc. They are also coming more and more here in India. I don't know how much core R&D, such as making machines smart machine, how much R&D is that happening in India? I don't know that, but eventually the question is, yeah, towards more like machine manufacturing. Thanks.
Very high level. I can't give you more details, but I can tell you that we have what we call as design authorities here. So it's not that, it's no longer the game that you're doing back-end support. We do core design authority. That means whoever designs it, whichever part of the world, he has to approve it. So to that level. We have also developed completely from ground zero, all the way full products which are being manufactured and sold. So there are some elements that we don't have the talent in India. Like I was mentioning during my segment, process capability was something that was missing. We have added that capability now. But full from design work, especially to the particular field that you say, right in my Chennai office, I have a large team that does that.
Understood. Thanks.
So we have electronic tool manufacturing associations in the country. Perhaps not on semiconductors, but we're making machine tools, and we have associations. Now, as far as semiconductor goes, there's one company, as everyone knows, ASML, which makes the most advanced lithography equipment in the globe. ASML doesn't make that alone. They have over 500 suppliers across the globe. Some of those suppliers, if one of those components is missing from America, whether it's a lens, whether it's a plasma, whether it's a tin, the whole thing falls apart. So probably to answer your question, India, of course, has aspirations to make this equipment in India. We must make the equipment in India for our national security. Today, they're our friends. Tomorrow, they may not be our friends. Can we allow that one single missing component to affect our national interest? The answer is no. However, semiconductor industry is a global industry. The machine can touch 50 countries. So probably what we can talk about in semiconductors is let's start. Let's work with Germany. Let's work with the United States. Let's work with our friendly countries and take subsystems and focus on those subsystems and then start forward and backwards integrating from those subsystems. Take what India does very well and start from there and be a part of that global supply chain, and then you can slowly start expanding. But if you think that India is going to build 18 angstrom lithography equipment, which costs $500 million in the next decade, it's not going to happen. So we have to be pragmatic and realistic also.
That's quite practical. Yeah, I understand. Thanks.
I'll also just add to that. So let's say back in the 2000s, from an EMS industry standpoint, none of the equipment was being built here in India. Today, let's say 20, 25 years later, the EMS industry has matured a lot. And I would say at least 20% of the equipment is getting manufactured in India within the EMS space. It could be simple equipment or it could be a bit complicated, like some X-ray equipment is getting manufactured. You have ovens, handling equipment, AOI machines, PTH AOI machines. So all of this happens with, as we were discussing earlier, partnerships, right? An ecosystem promotes itself. So until 5 years back, there was no fab, no OSAT, nothing. Today there's a fab, there are upstream, downstream companies. So equipment is getting, if not by an Indian company, but at least someone else is doing it, it's getting designed. There are upstream companies like OSATs who will buy the output of a wafer fab. And so that's how it self, it self circulates itself. Right? So even the equipment will come, and things like AI are definitely going to be able to drive it much, much faster.
Understood. Thanks. Thanks a lot.
Well, thank you, everyone. I have to close it. I got nasty stare from Raju here. Oh, food, of course. I'm keeping you from lunch. Thank you. Thanks, everyone, for your patience. And thank you to the panel for a fantastic session.
Thank you so much to all the panelists and the moderator. I now would like to invite Dr. Sasikumar Gendam, President Elsina, to please come on the stage and give away the mementos as a token of appreciation. We would like to thank Dr. Ravi Bhatkal, sir, for being the moderator of the session. Can we all give a huge round of applause, everyone? Come on, let's keep clapping. Thank you. Next, we would like to thank Mr. Sharad Kaul. Can we all keep clapping, everyone? Come on, let's keep clapping. Yes. Thank you so much for being a part of the panelists. We would like to thank Mr. Vikas Dabir, Senior Director, Business Operations, Applied Materials. A huge round of applause, everyone, for Mr. Vikas Dabir. We would like to thank Mr. Varun Manwani, Managing Director, Sahasra Semiconductors Private Limited. Come on, ladies and gentlemen, let's keep clapping a little bit louder, everyone. Yes. We would like to thank Mr. Ashok Mehta, Managing Director, Suchi Semicon. Thank you so much once again. Yes, let's take a group picture. Ladies and gentlemen, our third session will be on startups driving innovation in the ESDM domain. So yes, it will start sharp at 2:15. So I request everyone to please be back here. So it's going to be a lunch break now. Once again, I announce it's going to be a session on startups driving innovation in the ESDM domain. I request everyone to be back here at exactly 2:15 p.m. Thank you.